Hello everyone, I am Rishi Raghuvanshi. Welcome back to my YouTube channel. In this video, we discuss the topic model evolution. Let's start. Model evolution, a comprehensive guide. This video will guide you through the essential steps of evaluating machine learning models, including techniques, including techniques for dealing with unequal errors, cost, and interpreting your result. Defining the problem and objectives. First, problem definition. Clearly define the problem you are trying to solve and the specific tasks your model is intended to perform. Next, objectives. Establish measurable objectives from your model such as accuracy, precision, recall, or other relevant metrics. Next, we have splitting the data set. First, we have training set. Use the training set to train your model and adjust its parameter. Next, we have test set. In test set, use the test set to evaluate the model's performance on unseen data. Next, we have evaluating model performance. In evaluating model performance, we have accuracy, precision, recall, Ebb score. First, we first is accuracy, the proportion of correctly classified instance. Second, we have precision, the proportion of correctly predicted positive instance among all instances predicted as positive. Next, we have recall. In recall, the proportion of correctly predicted positive instance among all actual positive instance. Next, we have Ebb score. In Ebb score, a harmonic mean of precision and recall, providing a balanced measure of performance. Literally, model evaluation in Python refers to the process of assessing performance of machine learning models to ensure they are working as expected. It involves using metrics to measure how well the model is able to generalize to unseen data as well as identifying its strength and weakness. Here are key steps and methods for evaluating models in Python along with common metrics for classification and regression model. First, we have splitting data before evaluation. It's important to split your data into training and testing sets using train test split from sklearn model selection. First, we have to write from sklearn.model selection, import train test split. We use xtrain xtest, ytrain ytest, assigned to train test split xy test size 0 to random state 42. Training the model, we train the model on the training data. Here is the example using classifier like random forest classifier. In this, training the model in this from sklearn.ensemble import random forest classifier instant and train the model. First, we have to model assign random forest classifier. Next, we have model fit X train and Y train. Next, evaluating the model. Evaluating the model. Once the model is trained, we can use several metrics to evaluate its performance. Below are example for classification and regression model, are classification evaluation metrics. For classification tasks, the following metrics are commonly used: accuracy, we study precision, recall, Ebb score, very important, useful for imbalanced data sets or used when we more about specific types of error. Confusion matrix. It helps us to visualize true positive, and true negative, and false negative value. We have unequal errors cost. In unequal error cost, we have false positive, incorrectly predicting a positive outcome when the actual outcome is negative. Next, we have false negative. In false negative, incorrectly predicting a negative outcome when the actual outcome is positive. Techniques for handling unequal error cost. First, adjusting model parameter to favor certain classification. Second, using a cost sensitive learning algorithm designed to handle unequal error cost. Next, evaluating performance using cost sensitive metrics. Now, interpreting model evolution result. First, we have to identify strength, analyze area where the model performs well, and explore the reason behind its success. Next, identify weaknesses, identify areas where the model struggle and investigate potential causes for poor performance. Next, draw conclusions. Interpret the overall model performance, determine if it meets the established objects. Next, iterating and improving the model. First, we have featuring engineering. In this, we explore new features or modify existing ones to improve model performance. Next, we have algorithm selection. In algorithm selection, experiment with different algorithms and select the one best suited for the task. Next, we have hyperparameter tuning. In hyperparameter tuning, fine tunes the model parameter to optimize its performance. Next, we are presenting the final model evaluation. In this, we have executive summary in which provide a high-level overview of the model performance. Next, we have detailed result. In detailed result, present detailed performance metrics and visualization. Next, we have recommendation. In recommendation, we suggest next step for improving the models or deploying it for real-world application. The key takeaways and next steps for our upcoming videos are: model evolution is a critical aspect of machine learning life cycle. By carefully evaluating your model, we can ensure they meet your objectives and make informed decision about their deployment. Stay tuned for upcoming videos. Thank you.